May-June 2016, variant 33. The experiment is about the identification of metal in metal carbonate by measuring the volume of carbon dioxide collected. So the experiment starts from here. Metal carbonates react with dilute acids to produce carbon dioxide. You will identify the metal M in the metal carbonate, M2CO3, by measuring the volume of carbon dioxide produced during the reaction of M2CO3 with excess hydrochloric acid. The equation is also given. Fa2 is hydrochloric acid, HCl, and Fa4 is metal carbonate. Apparatus and chemicals include this water trough, 2 retort stands, paper towel, white tiles, a conical flask with a rubber bung with delivery tube passed and sealed, 50 centimeter cube measuring cylinder, 250 centimeter cube measuring cylinder, Fa2 solution, and Fa4 solid. Method. Read all instructions before starting your practical work. The diagrams below may help you in setting up your apparatus. So now here they have given us a diagram also, and if we look at the method, they have given us a long method explaining what they have done. Fill the tub with water to a depth of about 5 centimeter, which can be seen here that this is the water tub filled with water up to 5 centimeter depth. Then fill the 250 centimeter cube measuring cylinder completely with water. Hold a piece of paper towel firmly over the top. Invert the measuring cylinder and place it in the water in the tub. So here we can see that this measuring cylinder is filled and inverted and then placed in this water bath. Then remove the paper towel and clamp the inverted measuring cylinder. So here we can see the clamp is there. They have clamped it. Then so that the open end is just above the base of the tub. So its base must not be closed. It must be suspended a bit higher from the base. Use the 50 centimeter cube measuring cylinder to place 50 centimeter cube of Fa2, which is hydrochloric acid, into the reaction flask, now labeled X. It means this is the reaction flask, which must be labeled X, and then you have to take 50 centimeter cube of hydrochloric acid there. Check that the rubber bung fits tightly in the neck of the flask X, so that the gas which will form here will not leak from these openings. Then place the end of the delivery tube into the inverted 250 centimeter cube measuring cylinder. So now here we have this delivery tube which is passed under this measuring cylinder. Weigh the container with Fa4 and record the mass in the space below. Remove the bung from the neck of the flask. Tip all the Fa4 into the acid in the flask and then replace the bung immediately. Remove the flask from the clamp and swirl it to mix the contents. Swirl the flask occasionally until no more gas is evolved. Replace the flask in the clamp. Then reweigh the container and record the mass of Fa4 used in the space below. When no more gas is collected, measure and record the final volume of gas in the measuring cylinder in the space below. It means after filling this with water, when the gas will go here, so the water will go down and the gas will be collected from the top. And we have to record wherever the reading is, how much the gas collected here is. So let's start the steps one by one. Fill the tub with water to a depth of about 5 centimeter. Now let's take distilled water up to 5 centimeter depth. In this water tub. Now fill the 250 centimeter cube measuring cylinder completely with water. Hold a piece of paper towel firmly over the top. Invert the measuring cylinder and place it in the water in the tub. Remove the paper towel and clamp the inverted measuring cylinder so the open end is in the water just above the base of the tub. First of all, we will take the paper towel and we will flip this into a smaller portion so that once I cover this measuring cylinder with this paper towel, this water must not fall because I have to flip this measuring cylinder. So I have taken it a bit thicker now. Let me fill this measuring cylinder completely with water. Now, one more thing to remember here is we have to fill completely. They have written in bold. It means it must be filled enough that there must be no air bubble left. Let me show you how. Completely means like this. It must be complete. Now, once I have to put this in an inverted position, therefore I will move my hand, invert my hand first, and then I will cover this like this so that there must be no air bubbles. Now, once I flip, you can see there is no air bubble coming up. And then I will take this into this water bath and you can see there is no air bubble inside this water in the measuring cylinder. Now let me place this here. Before we place it here, let me show you that this is the tap. It is attached to the bottom. Now I will lift it a bit so that I can pass the delivery tube from the bottom. And I will hold this in the clamp. Now remove this paper towel. Now use the 50 centimeter cube measuring cylinder to place 50 centimeter cube of Fa2 into the reaction flask labeled X. And then check the bung fits tightly in the neck of the flask. Clamp the flask and place the end of the delivery tube into the inverted 250 centimeter cube measuring cylinder. So let's do it now. Now let me take 50 centimeter cube of Fa2 using this 50 centimeter cube measuring cylinder into the conical flask. So this is my 50 centimeter cube of Fa2 and I will take this in the conical flask. Now I will check whether the rubber bung tightly fits on this flask or not. So this is the rubber bung. It fits tightly. Yes, it is tight. Now let's hold this conical flask in this clamp and pass this delivery tube through this measuring cylinder so that the gas collected will go there. So I will pass this tube from the bottom into this bigger measuring cylinder. And to hold this tube, what you can do is you can move this measuring cylinder up to a bit lower level. So if you open from here and you take it a bit down, do not just press it so that the tube will be pressed. Keep it a bit loose. Now, the gas can easily pass through this tube to this measuring cylinder. And I have completed the task up till here. Now, weigh the container with Fa4 and record the mass in the space below. Container with Fa4 47.63. 47.63 is the mass of container with Fa4 recorded. Now, remove the bung from the neck of the flask, tip all the Fa4 into the acid in the flask and replace the bung immediately. Means there must be least delay in the time, or you can say the minimum loss of gas. Remove the flask from the clamp and swirl it to mix the contents. Swirl the flask occasionally until no more gas is evolved. Replace the flask in the clamp. So let's do it now. Now let's add this Fa6 into this conical flask. And remember, we have to replace this rubber bung as quickly as we can. So removing the rubber bung from this test tube, and now I will add and keep it pressed a bit so that there must be no loss of gas from the sides. Now the question has said remove the flask and stir occasionally. So let me open this clamp and remove the flask from the clamp and stir occasionally, and we can see the gas is continuously coming up. We will wait until the whole reaction gets completed and the maximum gas is collected. Now the reaction is almost over. Let's wait for a few more seconds so the reaction gets completely over. Now the reaction is completed. Now reweigh the container and record the mass and the mass of Fa4 used in the space below. Mass of container with any residual Fa4 is 4667. When no more gas is collected, measure and record the final volume of gas in the measuring cylinder in the space below. This is the inverted flask, so the volume here must be read upside down, and it is 114 centimeter cube. 114 centimeter cube. So the volume recorded is 114 centimeter cube. Now, let's record all these observations in the space they have provided below here. So I have recorded all the values here in the form of table for these 2 marks. Let's move on to the next part, which says calculations. Show your working and appropriate significant figures in the final answer to each step of your calculations. Now, appropriate significant figures means minimum you have to take 3 significant figures, and for better calculation you will take 4 significant figures in every answer you write here. Now the part 1 says use the volume of gas you collected to calculate the number of moles of gas produced. and assume 1 mole of gas occupies 24 decimeter cube under these conditions. Formula to calculate the moles from volume of gas is moles is equals to volume of gas, and if you are taking in centimeter cube, then divide that volume of gas by 24,000, because 24 dm cube means 24,000 cm cube. You will calculate the moles from this formula. Now, if you look back in the previous part, they have given you the volume of gas collected. And here is the volume of gas collected, 114 centimeter cube. So we will use this volume here, 114 centimeter cube divided by this 24,000, and we will get the moles of gas, which is 0.00475 for three significant figures. Now, the next part says, use your answer to 1 to deduce the number of moles of M2CO3 used in the reaction. Now, if we look back in the equation they have given in the first page, that was M2CO3 was reacting with HCl to form 1 mole of gas. So M2CO3 is making 1 mole of gas. So 1:1 is the ratio. So we will use this ratio here. The M2CO3 and carbon dioxide has 1:1 mole ratio. Therefore, we will use this moles of carbon dioxide gas 0.00475 to get the moles of M2CO3 used. So it's 1:1 ratio. Therefore, we will get the same moles, 0.00475. Now let's move on to the next part, which says use your answer to 2 and the mass of Fa4 used to calculate the relative formula mass of M2CO3. Now, if you want to calculate Mr from the given moles and the mass of Fa4 used in the first part, we can use this formula. Moles is equals to mass in gram divided by the Mr of compound. Now, if we look back in the previous page, the mass was given as 0.96 we used. So we will use this mass in gram, 0.96 divided by the Mr of M2CO3, which is to be calculated. And the moles we got in the above part, 0.00475. So in this way, if we calculate the Mr of this M2CO3, it is 202.1. Now let's move on to the next part, which says use your answer to part 3 and the periodic table on page 12 to identify metal M. Explain your answer. So if we have Mr of M2CO3 calculated above, we can use the Mr like this. M2CO3 is total giving you 202.1 Mr, where M has 2 atoms, so 2 times of M, and carbon is 12, 1 time, and oxygen is 16, 3 times, giving you the total 202.1. So if we calculate M here, it is 71.0. Now, if we look in the periodic table, there are different groups. So in which group this metal be present? So for this, we have to consider its formula first. It is M2CO3. M2CO3 means M has some charge here, which when crossed with the charge of carbonate, 2 minus. This is the way we write the formula. So we got 2 here and we got just once carbonate. Therefore, the charge here will be +1. And the metals which show +1 charge are in group 1. Therefore, we will just look this M in the group 1 because this is +1 charged. Now, if we look at the group 1, here if you look at group 1, the AR of rubidium is 85.5. Therefore, our metal is rubidium in group 1. And if we have to write the reason, we can say this way. Since rubidium is closest to the calculated AR and rubidium is 85.5. However, if you look above and below, cesium, which is below, has 132.9, which is way bigger than this, and potassium is, which is above, is 39.1, which is again far from this calculated 71. Now let's move on to the next part, which says C1. 250 centimeter cube measuring cylinder can be read to ±1 centimeter cube, which is actually the error because we have seen in our measuring cylinder, the least count was 2 centimeter cube. So the least count is 2 centimeter cube. Therefore, the error is read at the half of least count. That means the 1 centimeter cube plus minus is the error. So the measuring cylinder 250 is read up to ±1 centimeter cube. Calculate the maximum percentage error in the reading of the volume of gas. Now the percentage error has the formula. Percentage error is equals to the error in the instrument, error of instrument, and if we divide it by the measured value, whatever the volume or mass or anything you have measured, so measured value, and multiply by 100 for percentage. So in this case, if we look back in the volume of gas collected, it was 114 centimeter cube. So the error, which is just taken as once because we have read it one time, therefore we will take it just 1 over 140 times 100. So the percentage error in this case is 0.88%. Now, moving on to the next part, it says, it is likely that the volume of carbon dioxide that you collected was less than the theoretical volume. Give 2 reasons why this volume is likely to be less than the theoretical volume. In each case, suggest and explain a modification to the practical procedure that could help you to reduce the difference in the volume. So let's write 2 reasons with the modifications here in the space provided. Number 1, if we think about the oxide, that is carbon dioxide. So carbon dioxide is one of the acidic oxide. So carbon dioxide is an acidic oxide, and what it has to do with it dissolves. So it dissolves in water. And for your understanding, I'm just saying carbon dioxide, when dissolved in water, it forms a weak acid, which is H2CO3, carbonic acid. Therefore, rain is usually the acid rain because air contains carbon dioxide. So rainwater dissolves and it forms acid rain. Now, if it is dissolving in water and we have used a method where the gas was collected by displacing water, it means it was gradually and slowly reacting with water also. Therefore, a modification we can suggest here is use gas syringe instead of measuring cylinder. Instead of passing the gas through water for collection. So this is one of the modification that will improve our results. Now, the second reason could be the problem we have seen that it has started suddenly. As soon as we have added, it has started to react. So a bit amount of gas was escaped also. So the second problem was gas escapes before rubber bung inserted. Now, how can we improve this? We have used powder and we know that the surface area of powder is greater. Therefore, if we want to slow down the reaction, what we can do is we can slow down the reaction. And there could be two ways you can slow down this reaction. How? By using, number one, larger lumps of metal carbonate. So it will start slowly and you will put your rubber band quickly. Less of gas will be lost. Or another method you can suggest here is use lower concentration of acid. Again, it slows down the reaction because concentration decrease means slowing down the reaction. So here we comes to an end of 11 marks question from May-June 2016 33 variant.